I have one too many of these.
No, Colton, what am I going to get in return for the pencil?
Nothing.
So, never mind.
Here, you can have this pencil.
No. Is that mine? Is that the one you stole from my desk?
You know,
Screw
he
it.
said that he's gonna cry. And stole from my desk.
Yeah. If you want to trade me something for a pencil,
I ran out of lead.
I feel like that's
I just keep getting them stolen.
No one trying to get me in trouble.
Oh, my friend.
collateral damage.
Yeah.
So you have to go back
I'll get it back.
that day with the collateral.
Here, Castle, can I borrow the pencil and give it to Nolan? Not Nolan, Colton.
What am I going to get in return?
My wallet.
Okay. Oh. That's bad.
Oh,
Here you go, Colton.
I'll hold it.
Thanks, Braynon.
Don't look at it.
Are they not allowed to borrow from you anymore?
No, I'm having people trade me something now because I keep losing pencils.
Why won't you trade something?
How do you have no one?
What's the
Makes
point
sense to
of
me
this
too.
thing?
Hey, Trooper Tie Tuesday.
Boo.
Okay. February 4th,
Nobody cares about
2020. Okay.
And just
Geometry, SWVA, students will be able to use perpendicular and angle bisectors to find measures. Okay, so we're going to first talk about what a perpendicular bisector is, and then we're going to start using it and applying it. Okay, kind of like you always do. What?
How long have you still defined it? Like, we've been here for like.
You
how
like
long?
go at him all the time though, like you don't give it a break. You're like,
How
yeah?
How
You
long
wanna
have you
go,
been in
boy?
this class?
What?
How long have you like been
Will
in
you
class with you?
calibrate
Not
your
like today,
pen,
but like
please? It's
how
really
many months
bothering
we've been
me.
in class with you?
Well, okay, when do we start school?
We have like
January, February, March, April, May, June, July, August, something?
We have
August,
like
okay.
3.5
August,
months left, guys. It's
September,
gonna be okay.
October, November, December, January,
When?
February,
When?
so 6 months.
You've been with me 6 months.
So you still have to define
When did I
SWAB.
ask?
Yeah, you like SWAB, students will be able to.
Yep, every time.
Because now they're required.
Can you
to do
calibrate it and tolerate it?
Okay.
That's how we're
I'm
supposed to
serious.
do it.
How are you writing with it? You're gonna do it sometime. I'm sure.
You just get used to it.
No.
Okay.
I don't want to do the.
Well, now it's not even. You can't even see, bro.
Hey, I live by faith, not by sight.
Well, guess what I live by?
You can say what you want without the clever. Okay.
Girl, I live by never knowing what's happening and not liking that. And despising Mr. Constantine.
Probably. Okay. A little rude. Okay. Let's not. Like, I'm glad I know you're working, but. Oh, great.
I don't know how to do that.
Who's it bad?
How many pages are we gonna do?
We're gonna go through 6.1 today.
Well, I'm saying who's your dad? So you
Ooh, get wrecked.
You know what's really funny? If you want to see somebody get wrecked, you should always like watch Trump like wreck everybody he goes against. It's so funny.
Okay.
Like he's always roasting the crap out of them.
Hey guys. Let's dial it in
Trump uses.
for our lesson.
Hey, that's part of geometry.
Hey, no, it's not.
Oh.
Nolan, I've asked you to stop. Thank you. Okay? Say me to your butt off.
You're like
Yeah.
your butt out.
Okay, Colton.
We didn't hear you.
Hey, Colton. Colton. Look at me.
Colton, look.
Are you a teacher? No. I can. Okay, thank you.
Oh, just wait till I become your boss.
Okay, cool. Okay.
I hope I'm not a principal. You know
Yeah,
how well
fit a new job into that, okay?
Rules.
Perpendicular bisector
That'd be so
is a
weird.
segment, ray, line, or plane that is perpendicular to a segment at its midpoint. So it's a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. So if it bisects something, bisects means it cuts it in half, okay? So it cuts the segment into two congruent parts. It cuts the segment into two congruent parts. Okay? And what does perpendicular mean?
It means perpendicular across.
At a
Angle.
what kind of angle?
Midpoint.
90 degree. Perpendicular means it crosses at a 90-degree angle. Okay? So here, which one of these two things is doing the bisecting? CP or AB? Line CP or segment AB? Which one is bisecting?
CP.
Line CP is doing the bisecting.
I
So line CP is doing the bisecting, and what is getting bisected then?
maybe.
Segment AB is getting bisected. We can tell because of the way it is. Okay, we can tell because AP is being marked congruent to PB, so P has to be the midpoint of that.
Remember when we did the eye cut thing?
No, I never did that.
You never did that?
No, I go when I was in like elementary, middle school. Yeah,
Yeah,
I
it was
thought you meant like last year.
No, it was like well, eye cut.
Oh yeah, I know that is.
Ew, dude. So
Yeah,
you
stop.
see me pee?
Okay. Okay, hey, let's focus back in. Let's focus.
Why is this fun?
That's what you said after. Ew, dude. Gross. You got a bathroom in me?
Perpendicular bisector theorem. I'm gonna keep teaching. If a point is on the perpendicular bisector of a segment, if a point is on the perpendicular bisector of a segment, so in this case, C is on this perpendicular bisector, or down here we have the same picture. C is on the perpendicular bisector, because this is bisecting AB and it's perpendicular to it. So if a point is on the perpendicular bisector, like C is, then it is equidistant from the two endpoints of the segment. And it is equidistant from the two endpoints of the segment. And I need to take that picture out of there. I don't want it on there.
You have to remember.
It's equidistant from the two endpoints of the segment. What do we think equidistant means?
Equal distance.
Equal distance. Okay.
Why can't it be like two separate words? Equal distance.
Matt's
It's a word. No?
Equal distance.
It's a word. Equidistant.
What if I just threw this out there and it broke?
Then I'll be.
So
That would be so amazing.
because C is on this perpendicular bisector,
I take this out.
Hey. because C is on this perpendicular bisector, we know it's equidistant from which 2 points?
C to P. And P to P.
From the two endpoints of the segment. What's our segment here that's being bisected? AB. So C to A and C to B would be the same distance. We're saying C to A and C to B would be the same distance. Let's please draw that in there. Okay?
Oh, I need a ruler for sure.
I'm not.
What did Clyde or Sam do?
I should throw
I just assumed it was
Wait, you want us
something
to
else
scribble
doing
out
Probably
that
Clyde.
one? I just
Yes.
assumed.
I know your face is
I'm
pretty
going
looking, I know.
Okay.
Dude, your hands are always dry, and it drives me
Oh my
crazy.
gosh.
I'm
So,
sorry.
So what we're saying here is C's on this perpendicular bisector. It's going to be equidistant from the two endpoints A and B. Okay. Moving on to the converse. Converse means the same thing, but we switch the order. So we're saying if a point is equidistant from the endpoints of the segment, so here X is equidistant from A and B. X is equidistant from A and B. We're saying then it must lie on the perpendicular bisector. That's our logo for perpendicular. Perpendicular bisector, which I'm going to abbreviate as BIS like we have before. Then it lies on the perpendicular bisector of the segment. It's the same idea as our perpendicular bisector theorem. We just switch the order. So we're saying
Does that say BIS?
for bisector. Okay? So if segment XA is equal in measure to segment XB, then X must lie on the perpendicular bisector of segment AB. It's just saying the same thing we said a moment ago in reverse.
That's a little silly.
So it works both ways. If X is on the perpendicular bisector of the segment, it's equidistant to the endpoints. If X is equidistant from the midpoints, it has to be on the perpendicular bisector of the segment. Let's look down at this example. It says extra example 1. It's really just an example 1. I had one of those last semester too, or last chapter, too.
Yeah.
Okay. So it's just where it got pulled from. It just happened to be called extra example. Okay. So we're told in this diagram, RS, this line at RS is the perpendicular bisector of segment PQ. We're told RS is the perpendicular bisector of segment PQ, and we're asked to find the measure of PR. Okay. Well, if RS is the perpendicular bisector, what information can we mark down here? What does it mean for it to be a perpendicular bisector? Okay, it means S is the midpoint. So what do we know about PS and SQ? They're congruent. Okay, and what do we know about this angle? 90 degrees because it's a perpendicular bisector. Perpendicular means it intersects to form a right angle. Okay. Now, is R on this perpendicular bisector? Okay.
What did you just ask?
Is R on the perpendicular bisector?
Yeah.
Yes. If RS is the perpendicular bisector, R is on it. It's literally part of the name. R is on the perpendicular bisector. So according to the perpendicular bisector theorem, put that away. According, you're not using it right now. It's a distraction for you. Okay, were those good enough reasons?
No.
I was using it for make lines.
So, R is on the perpendicular bisector. So according to the perpendicular bisector theorem, it's equidistant from the endpoints. So R is equidistant from which 2 points? At P and Q. Thank you. R is equidistant from P and Q, so we know this segment and this segment, RP and RQ, are equidistant. What can we now do with that information?
Plug it in.
Nope.
No.
Find X. How do we find X? Make an equation.
Yeah.
What equation do you think you can make?
8x minus 9 equals 6x.
Yes, we can. And we're able to do that because they're marked congruent. Congruent means they're the same measure. So we set their measures equal to each other. Whenever we hear congruent, we should always be thinking set them equal. We should have cowbells going off in your head.
I always think
Telling us to set them equal.
Cowbell. Look at that.
Okay.
Okay, you have your
Thanks for putting that away.
Sorry, they're doing my family group chat, and they're like texting last night. I have this strange history.
So thanks for putting that away.
How about the 49ers?
Okay. So how would I solve this equation, guys? I have to move all my x's to one side, don't I? Would I rather move my x's away from my numbers or my x's toward my numbers? Probably away, because we want our x's away from the numbers, so let's subtract 8x. Negative 9 equals what number? Negative 2x, thank you. Now what would we do? Divide by negative 2. Okay, divided by negative 2. Now we could either call this a decimal or we can call it a fraction. What's a negative divided by a negative? It's what kind of number? Positive. So it's going to be positive. So that's going to be equal to a positive number. We can either call it 9 over 2. We can either call it 9 over 2 or we can call it what 0.5? Anyone know? 4.5? You can call it 4.5 or 9 over 2. Either one is fine. But now we're asked to go back in and find PR, aren't we? Okay, how do we go in and find PR? We're on this one. Okay, we gotta plug it in. Plug it into 8x minus 9. So instead of 8x, okay, 8 times, now I'm going to do the 9 over 2 because I actually think the fraction is going to be easier on this one.
It's 27.
If I think this is an 8 over 1, can I cross simplify my 8 and my 2? Cross reduce? Yeah, what goes into both numbers? What goes into both numbers? What goes into both 8 and 2? 2. 2 goes in 8 4 times, it goes into 2 once. What is 4 times 9?
Huh?
What is 4 times 9? 36 over 1, so just 36. And 36 minus 9 is?
That's 27.
27. So the measure of PR, as Colton said a moment ago, is?
I just did that quick.
The measure of segment PR, as Colton said a moment ago, is?
27.
27.
27.
Could we plug it into QR just to double check? Sure, and you should get the same thing, right? If you didn't, you did something wrong. Okay? Questions on that? Everybody stand up real quick. Everybody stand up real quick.
Good, 'cause I'm backwards.
Okay. Yep. Everybody stand up. Yep. You're in this
You were
class,
the one
yeah.
that wanted to do this.
Me? I
Okay.
never said anything.
So,
At least today.
first thing, we're gonna stand up. We're gonna reach up. Everybody do this. Reach up. Okay.
As far as I can go.
Everybody reach up.
In your bed.
Everybody reach up.
Go on, Casey, do it.
Okay. Everybody bend over, touch your toes.
Oh,
God, don't do this. If you can't.
Ah,
Okay, I just wanna make sure.
touched it.
Bend over, touch your toes. Okay. Stand back up straight.
This is legit.
Okay, kind of tilt to your side. Tilt to your side.
Oh my god.
Stretch out your sides.
Oh,
Okay, tilt to the other side.
girl.
No leg. God.
Stoner. Right arm across your chest. Ready?
And then we're gonna do 2 jumping jacks. 2
Stop!
jumping jacks.
Go.
Okay.
Done.
1, 2. Okay. Kale, do it again.
Done.
AKA do it for the first time. Okay.
Coley
There you
didn't do
Casey
it.
didn't do it. Casey didn't do it. They have to do them.
That's
It's
weak.
required.
Go ahead and sit back down.
Nice try.
Freaking kids these days, I swear. Kids these
You wait. until I'm-
Okay. Golden. Golden. Get back in your seat. We're starting. Example 2 in the diagram. JK is a perpendicular bisector of segment GH. Line JK is a perpendicular bisector of segment GH.
GH.
What segment lengths are equal? Anyone tell me a pair of segment lengths that are equal if we know that JK is a perpendicular bisector?
HF.
Okay? HF and GF, they're both marked as 4.1. Segment HF is congruent to segment GF. They're both marked as 4.1. They're the same measure. Okay? Can anyone tell me another pair of segments that are congruent here? Gracie.
GJ. Oh, never mind. GJ and JH.
They are congruent. How do we know that those are congruent even though they're not marked? How do we know they're congruent even though they're not
Because
marked?
they are J's intersecting both of them, so they are.
J is on the perpendicular bisector because JK is the perpendicular bisector, so it's equidistant from the endpoints, G and H.
Why is your line so far down?
So which one?
For the 4.1, is it supposed to be that far down?
It doesn't matter.
He's just kind of bothering me though.
That'll be fine. So segment JG is congruent to segment JH, like Grace said. Okay. What else do we know are congruent? What other 2 segments do we know are congruent?
GJ and J. Look at one. JK. Wait, that's the bisector.
GK and KH. Because JK, line JK is bisecting it. So it's cutting it in half. The segment GK is congruent to segment KH.
That was a little.
Okay? So, now could we find the measurement of segment GH since we know all these parts are congruent? Can we find the measurement of segment GH, the whole bottom?
Yes.
How would we go about that?
X plus 1 equals 2x.
Okay? X plus 1 would equal 2x. Those 2 segments are congruent, so we can mark them as congruent. I don't know why my pen is tripping up like crazy today.
Tripping? Because it's 420 today.
It's not 420 today.
Technically.
I mean, I guess it could be.
Yeah.
You're right,
Yeah.
it's 420.
Yeah.
Did you know it's 2-4.
Hey, we're pretty close to Colorado.
answer to Van? It's 2-4.
2-4-20.
Oh! I just got that.
So, how do we solve this one?
X equals 1.
How do we solve this one?
Minus x from both sides.
Very good.
You get x equals 1.
X equals 1. How do I go back and find GH?
Plug it in.
Plug it into both. What's 2 times 1?
2.
What's 1 plus 1?
2.
What's 2 plus 2?
4.
So the measure of segment GH is 4. 2 plus 2, that's 1. Minus 1, that's, or excuse me, 2 plus 2, that's 4. Minus 1, that's 3. Quick maths. Okay, maybe like it more this time. So the measure of segment GH is 4. Questions on that?
I have a question. Why are we learning this? When are we gonna use it?
Okay.
Yeah,
I can answer that question more individually after class. Cool beans?
On the homework
Okay, because so
today.
far we've already been pretty darn distracting from our lesson, so I'm not gonna have any more time to distract us from our lesson right now. Okay, but we can later. Cool
We
beans?
have
Cool beans.
28 minutes left.
Look at the following pictures. Segment AB is the perpendicular bisector in each of these triangles. So first triangle, segment AB is a perpendicular bisector. Second, third, fourth, all these triangles, it's the perpendicular bisector. It's perpendicular to a side and it's cutting a side in half. What do we notice about these perpendicular bisectors though?
They all have 90 degrees.
Okay, yep, because they're perpendicular, so they all have 90 degrees.
They all have an angle bisector.
Okay, not an angle bisector, they all bisect the segment.
Yes,
They're
and
perpendicular
they
bisectors.
all are bisected.
What do we notice that's different in these?
They're not the same shape. They're not.
They're not all in the middle of the triangle, are they? On our picture, on a lot of our pictures, we had it going through the middle of the triangle. This would be the vertex of the triangle. Here, they don't have to, okay? That's why I want you guys to pull away from this, and I want you guys to write that here. My pen is being crazy
Your
today.
pants?
My pen.
Whoa.
The perpendicular bisector does not have to go through the vertex. Thank you for writing this down, Grace. Does not have to go through the vertex.
Thanks for what?
Writing this down.
Yes.
Of
of course.
the triangle. Thanks for writing this down.
Yeah.
Appreciate it. For anyone wondering, 4 months and 23 days, by the way. If you're curious.
Wait, what are you guys getting married? April what?
June.
Where are you guys going for the honeymoon?
June? Wait,
So we're gonna go to a few different places. We're gonna go down to Utah. We're gonna go to
Salt
some
Lake
different national parks down there. We're gonna fly into Salt Lake, and we're gonna go to some different national parks down there, like Zion, Escalante, and like gonna go to like Salt Flats. So we're gonna be in Utah for a few days, and then we're gonna go down to Mexico, and we're gonna go into like it's called Merida. It's like on the Yucatan Peninsula, and so we're gonna hang out there for like 2 weeks. So we're gonna go. Our honeymoon's gonna be 16 days. Pretty happy about it.
Sounds like
And we're like Airbnb-ing it up and like cheap flights and everything like that. So like we're trying to do it cheap and stuff too.
Did you guys do
It's
your
called
flights
Merida.
now?
It's on the Yucatan Peninsula. What?
You guys do your
Where's
flights
it
now?
near?
Yeah, like we only have one flight left to book, but I'm like, it's like I applied for like airline credit cards, so that way I can get like bonus points, and so buy them with bonus points instead. So
Is it like, are you saying a resort?
No.
No. Oh, I would be careful.
yeah, that part of Mexico is a lot better than some other parts. So
Yeah.
try not to.
June what?
June 27th.
Just don't let your fiance or your wife go.
I'm part of
and
the
get
cartel,
back
so
to
it's alright.
What did you say?
I'm part of the cartel, so it's alright.
Oh, of course. No dog will let me
Wait,
go through.
are you gonna like show us pictures or
Cartel
stuff like that when you come back?
I mean, I probably won't have you in class,
You cartel.
but if you ask me, I'll show you.
If you pass me.
I mean, I won't have you in class, so.
Wait, why not?
Me and you.
I'm good with that.
I'm a
Do
junior.
you only teach sophomore?
We're gonna skip this part for now, but we're gonna come back to it later. Don't cross out this part. We're gonna skip this part for now, but we're gonna come back to it later. Okay, so don't cross it out. Okay. Angle bisector theorem. Angle bisector theorem. So we talk about perpendicular bisectors. Now we're gonna talk about angle bisectors.
Bad.
Okay. If a point is on the let me try that again. If a point is on the bisector of an angle, then it is equidistant. What is that word again? Equidistant. Sure. It is equidistant from the two sides of the angle. From the two sides of the angle. So we're saying if a point is on the angle bisector, it's equidistant to the two sides. and we measure distance along the perpendicular. I'll explain what that means in a moment here. So we're saying if D is on this angle bisector, so we're saying if AD, ray AD is an angle bisector, it's cutting this big angle in half, which we see it is by these arcs, then D is going to be equidistant to the two sides of the angle. We're saying D to B and D to C is going to be the same distance. Okay, we're going to say it's going to be perfectly in the middle of those two. But we have to measure this distance along this right angle. We have to measure this distance along the right angle. Okay, and let me explain a couple reasons why. First reason, okay, if I go to this wall, can I do it in multiple places? Can I go to that wall in multiple spots? Yeah, and would some be shorter than others? Yeah, they'd be different lengths, okay? So like maybe from here, I take 1, 2, 3 steps, I'm at the wall, okay? Or as I come back here, let's say I'm going over there to the part of the wall over there. Is it still going to take me 3 steps? Okay, unless I'm like a giant. Okay, unless I have like
Yes,
Nolan's legs,
5,
and maybe,
right.
but otherwise probably not, okay? 1, 2, 3, 4, 5. Boom, okay?
Yes.
So, just because I could go to the wall in 2 different spots doesn't mean the wall is a different distance away from me. It means that spot on the wall is a different distance away from me. The wall, the distance from me to the wall, is the shortest distance. Just because we can drive to Bellevue by going through Iowa first and going around does not mean that's how far away we are from Bellevue, right? Okay? Because is that the shortest distance to Bellevue? No, we measure along Highway 75. That's the shortest distance to Bellevue. Although you can get there through Iowa, like I actually had to during the flooding, right? And then we had to go through like Louisville last year too, and Springfield.
Unless you drive your own
and so-
helicopter to faster.
What?
You drive your own helicopter.
Yes, because someone in plastic.
Yeah, I'm sure that's accurate. Okay.
Yeah.
So we measured along the perpendicular, guys. We measured along the perpendicular because that's actually going to be our shortest distance. That's actually going to be our shortest distance, and that way we know it's the same. That way we know the distance is the same. So that way, if we look up at this picture, I'm not going from D to the side, and I'm going like up here. Because then I could be saying, oh, well, this distance right here that I just drew in purple is going to be the same as DC, because that's just not true. Okay? So I go to the perpendicular, because that way it matches up. That way it matches up, so that way we know we're actually talking about the same distance. So if the measure of angle BAD, this measure, is equal to the measure of CAD, aka if this angle is bisected, then we know that segment BD is going to be congruent to segment CD. That's what the angle bisector theorem is saying. If a point's on the angle bisector, it's equidistant from the two sides. Points on the angle bisector, it's equidistant from the two sides of the angle. And then like I explained a little bit there, measure distance along the perpendicular, that's going to be the shortest distance. Okay? That way we're not meeting up at 2 different spots either, okay? Once again, we have a converse where we take the same information, we reverse the order, and this converse is also true. So if a point is in the interior of an angle, if it's inside an angle, and it's equidistant from the two sides of the angle, so if D is inside this angle, and it's equidistant from B and C from the two sides, then it lies on the bisector, of the angle. So if the measure of segment DB is equal to the measure of segment DC, then we must know the measure of angle BAD is congruent to what is equal to what measure? CAD. Very good, Jillian. I can mark that on our picture now. So we're saying if D is inside the angle and it's equidistant to both sides, you know, make sure it's at a right angle, so we know it's the same distance. Then it has to be on the angle bisector. So we know ray AD has to be the angle bisector. Questions on that? Yep, always.
Awesome.
Super eager.
Okay, so why don't I?
Okay.
Or did you just forget that?
Like last time we put the congruent, this time we put equal. So we could put, so if you wanted, you could do angle BAD is congruent to angle CAD. Man, my pen is going crazy. I'm lifting my pen, but it's not saying anything. Oh, now it's gonna crash on me. I just have this bad feeling. Good. That's a little rude.
You're hot.
BAD.
Ew.
CAD. Or Grace, you were saying, or it up here.
In our.
You were saying
Wait,
here?
yeah.
Okay, so if we had the measures, you set them equal, because these are numbers then, because a measure of an angle is a number.
Okay.
But
How does it
the
matter?
actual angles are
How
congruent.
do you draw your D's? He goes.
This
he goes.
essentially came up
He
very
goes
well.
like this. Watch it.
Yeah.
No. And with his B's, he goes. Wait.
Because
That's
you
why
draw
you
Ew.
one.
From the top.
Why?
Weren't you making fun of Celeste the other day? 'Cause she does it
Yeah, she does her S's.
from
But
the
you draw
bottom.
your D's and B's the same way.
That's back.
No, I go from the top for my D. Top, down.
No,
Top,
that is
down.
not correct.
That's not how you do it.
It's less strokes.
Top.
No, but then I don't have to lift my pencil.
Wait, is that a
I do like
backwards?
you.
Okay, but they're really squashed. That's there, that's better.
Why are y'all
B.
roasting
Like,
Mr.
it looks
Johnson's
like
handwriting?
a backwards B flat with a little finger. It's annoying. Wait, do a B more.
I did.
No,
did
no,
it.
that's not normal.
Try-
tried that. He like so. There you go.
Yeah, why
can't you do it like
Oh.
that?
Why
I
is it
was
so-
slops.
Ew.
Probably
Why can't you
equally.
draw
Like the
regular
bottom
B's?
should always be
You
bigger than the
can't.
top one. Mr. Castle, draw a 3 and
Now
make
make
it
a line
bigger.
on it.
Yeah, make it bigger. The
No.
top is smaller than the bottom.
No.
Make the bottom bigger.
You're
Make
so
the
bad.
bottom
Oh
bigger.
my god.
Okay,
Oh.
so decide whether the information below allows you to conclude that C is on the bisector of angle A. So is this enough information in number 1 to say that C was on the bisector of angle A?
No.
Yes.
I heard some no's and I heard some yeses. Braden, why do you say yes?
Well, because C looks like it's the midpoint of those two angles.
Okay, so C's,
Basically on each side.
so you're saying C is congruent to each side. So we know this C to this side and C to this side are the same distance, okay? And are we measuring along the perpendicular? Okay, read the angle bisector converse one more time. If a point is in the interior of an angle and it's equidistant from the two sides of the angle, then it lies on the what's the angle bisector converse? Then it lies on the bisector of the angle. So is C on the bisector? Yeah, it's equidistant from the two sides along the perpendicular. So is this enough information to conclude that C is on the bisector of angle A? Yep. Even though we don't see this line going through, we can notice by the measure of how far it is from the sides that it is. Those of you who said no, were you going to argue that you can't see the line? Yeah.
No, I didn't see the 3 points. I didn't see-
Oh.
So, like, it's bigger than most, like, no, never mind. So if it's like that little circle, it's not a point, it's just a bisector. Like, not a point, but like, it's not, you know, a
This
line.
point is on the bisector.
It-
It is on the bisector. We haven't drawn the bisector, but it's on the bisector.
So is it a part of the line? Yeah.
The point is not a line, the point is a point.
That's just
A point is a point. This point is on the angle bisector.
Okay, but what about the second one?
Okay, yeah, we'll get there now. So on number 2, is this enough information to conclude that C is on the angle bisector?
No.
No, someone said no. Why not?
Because they're not equal to 4 centimeters.
4 and 2 are not the same length, are they?
No.
So C is not equidistant to both sides, is it? It's 4 centimeters away from one, 2 centimeters from the other. So, no, this one's not on the angle bisector. Even if we didn't have this arrow coming out, this ray coming out, we would know it's not on the bisector because it's not equidistant to the sides. At the perpendicular distance, because that's our shortest distance as we talked about, me going to the wall. Number 3,
Yes.
okay, I heard a yes,
No.
I heard a no. Fight,
No.
okay?
Yes.
Okay, Emily, why are you saying yes?
Because they're both 3
They're both 3 inches, okay, so it's equidistant. Okay, Clyde, what are you saying? Why are you saying no?
The C is not like in the middle.
Okay, because the C's not like in the middle, so the C's not here?
Yeah.
Okay?
But it doesn't.
Doesn't technically need to be, okay? Okay. Well, what do we notice here about this angle? And what do we do about this angle?
Your shoes are They're not right.
Okay, they're not right angles. And how do we want to measure our distance? What did I make a big deal about measuring our distance? How, guys?
I see.
At what kind of angle? A right angle.
Right.
Okay, so we don't know that these angles are the same. We don't know that these angles are the same. In fact, they look like they're different angles. So even though it's equidistant to this point and this point, we don't know it's equidistant to the sides truly, because we don't know how we're approaching the sides. So no, not enough information.
Can you tie your shoes? It's kind of making me nervous. Not gonna lie. Wait, how do you tie
Let's go to
your
the next.
shoes?
Like a
He,
normal person?
no, depends. He's like doing the
Are you
bunnies.
assuming I
The
tie it off?
bunnies and the.
Okay, wait, no. Okay, wait, never mind. I thought you were gonna do
Y'all
bunnies. I was like, oh my
overreacted.
god.
I did bunnies.
8-year-old. 8-year-old.
Okay.
He's gonna do the bunnies.
Yeah, I thought you were going to pay attention. Okay. Example 4.
Oh, you're wrong.
Find the measure of CD. Find the measure of segment CD. We're trying to find this measure here. We're told it's 6x minus 7. Colton, what are we told about segment BD?
Tying my shoe.
Okay, I tell you my shoe, Mr. Carlson.
Oh!
How much
I was wondering when you're gonna make a dad joke. Hi, I was wondering when you're gonna make a dad joke.
I'm not that. Woogie, 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 woogie.
Hi, I'm Grace.
My favorite thing in the world, Jillian, don't diss on it.
You said I'm Grace. Hi, I'm.
Oh, not that. Woogie, 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 woogie.
Hi, Shinsky. Hi, Grace. Got you.
So,
That was my whole master plan.
we know that BD and CD are what?
Ruined.
Congruent. So what can we do with these measures?
Plug them in equal to each
Set
other.
them equal. If we're finding a measure, we're probably going to have to make an equation to find x. Plug it in. Okay? Now we use our algebra skills to solve this equation. How would we go about and do it? Sam, what would be the first step? Here you had a pretty good algebra 1 teacher, so what would be the first step?
Subtract 3x.
Subtract 3x.
4.
5 is equal to 3x plus, excuse me,
7.
that's supposed to be a minus 7.
Yes.
I was wondering what the heck that
I
was.
know. I just felt something that was wrong. And then.
Okay? Yeah, I heard you also had a pretty good algebra 1 teacher. What would you do?
No. Yeah,
Add 7 to 5.
Add 7, Cal. I thought you had a good algebra 1 teacher.
I thought so too.
Did you just get like a 95?
I thought that 3 wasn't with that.
Well,
Yeah.
your
Yeah, it
fault.
is. What would you do?
Then I add the
Add
We have
the
the
7.
same algebra teacher. That's why.
Actually,
12 is
Yeah.
equal to
Oh, makes
3x.
sense now.
Eggs. I thought the eggs.
Okay. Who else in here had a pretty good algebra 1 teacher?
Actually,
Grace, you had a pretty good algebra 1 teacher. What would you do?
So did I.
Okay, let's go to someone else.
No, I know.
Nice.
You divide by 3.
I know. I just knew that if I said go to someone else, you'd answer. So x is 4. Are we done once we found x?
No.
No, we gotta plug it in, okay?
No.
So, where do we plug this in at?
10 minutes.
3x plus 5.
Okay, well, which one's CD?
6x. Minus
Now, should it actually matter which one we plug it into?
Yeah.
No, but
No.
we can plug it in both. Be careful, but technically 6x minus 7 is CD. So 6 times 4 minus 7. What is 6 times 4? 24, haha. What is 24 minus 7? So the measure of segment CD is equal to 17. Very good. Or, excuse me, Nolan. Hold on.
Say what?
Okay.
What? What'd you say?
Question on number 5. I said, very good, Colton. And I said, excuse me, no log. Okay. So number 5.
My parents don't like it.
Find x. We're told these two measures the angle are 3x minus 5 and 2x plus 5. Stop. Stop. Okay, we're told, stop. Thank you. We're told this angle is 3x minus 5, this angle is 2x plus 5. And we know this point is equidistant from here and from here. So what do we know about this point? It lies on the
Bisector.
bisector. So we know this angle is cut in half. So we know these two angles are congruent.
Yeah.
So what can we do with those? Set
90.
them equal. 3x minus 5 is equal to 2x plus 5. Now, Mackenzie, I hear you had a pretty good algebra 1 teacher. What would you do? Okay, subtract 5. You do that. 3x minus 10 is equal to 2x. Okay, now that we have 3x minus 10 is equal to 2x. Okay, I think we're running out of students I had. But, Gracie, I hear you have a pretty good algebra 1B teacher. What would you do?
I had a pretty good algebra 1 teacher.
What did you ask?
What would you do? 3x minus 10 equals 2x.
I would
Miss Sidlick was a
you
god.
would
So.
take one of them, like you would subtract 2 from itself.
Okay, not 2, but we need to subtract, move 1 away from the numbers.
Oh yeah, you would subtract it. Sorry. I'm sorry, I'm doing it pretty bad.
Negative 10 equals negative x. No dog, I hear you had a pretty good algebra 1 teacher apparently. It wasn't me, but I heard she was pretty good. Okay?
Yeah.
So what would you do?
Where we at right now?
Okay, negative 10 is equal to negative x.
Oh no. Divide.
Divide by
Negative x.
negative 1. Close.
Obviously. Well,
So
then it
x
goes
is equal
10.
to 10. Are we done?
No.
What do you think?
Yeah, what were we asked to find? Last I checked we did. Okay? We're going to skip example 6 right now, and we're going to skip the bisecting an angle for now. Don't cross them out, we're going to skip them for now. Okay?
My wedding ring doesn't look like this. I'm getting divorced.
That's very aggressive.
I'm not
but I
saying
don't
yes.
suggest that.
I'm not saying yes.
Okay, that's all very aggressive, but I
If
don't
it's not a
suggest
big
that.
diamond, you got me all wrong. What if you love it and it just broke? Then I won't love it.
Wow.
Grace falling in love with a broke guy? Yeah, right.
Yeah, she's gonna be like, you need a jar.
I would never.
You need to wear Louis Vuitton clothing and give me.
You have to own 5 votes. Own 5 votes?
I mean,
Move
they
it.
can be fine.
I got
Jet
you.
ski. Jet ski's pretty cheap. That's considered a boat.
No, Grace wants a yacht with like a
got.
You want the TV and the couches at night. Carriage.
Like,
board.
what?
It matters.
No, it doesn't.
I'm an extra gold digger.
Because my phone was.
Yeah, you
She
really
is.
are.
She's gonna be living the high life.
Hey, I have a note on number 6.
Don't do it.
Yes. Don't do number 6.
We need to know on number 6 that wine PM, excuse me, Ray PM.
It's really double-sided. What the heck?
Ray MP is creepers.
That's a naughty word.
Ray MP is the perpendicular bisector of segment LN. We need to know that MP, Ray MP is the perpendicular bisector of segment L. We need to know that for number 6.
I can't wait till I can get married. Like,
Yes,
look how
Brady.
pretty
I'd like
I'm
to trade
with.
this pencil into my wallet.
Yes.
I'll just go over it again.
Grace, you gotta find a guy to get married.
More to marriage than just the ring.
Yeah, or a woman.
Or a girl. I didn't.
No, that's not what I meant, but I'm just saying. Why do you do that? You're like, yeah, she likes.
Is that an Apple Pencil box back there? Yep.
Will this just be like 90 then?
Let's go, my money's still in here.